solving inequalities. An inequality is like an equation, but instead of an equal sign, it will have one of these signs. So the inequality symbols, we have the less than symbol or the less than or equal to symbol. So when we have a variable on the left-hand side and we have an inequality that points to the left, that is the less than symbol. If it has a line underneath it, it also means it's less than and equal to the number. So it can also include the number it's less than. And then we have the greater than or the greater than or equal to symbol. So when we have an X on the left-hand side and we have a symbol pointing to the right, that is the greater than symbol, and it's greater than, and if there's a line underneath it, it's greater than and also equal to. So these are our inequality symbols. And we're going to be using the number line that you see on the bottom, and we're going to be graphing our solutions. Now I just wanted to bring in this one little tip. When you're trying to determine what an equality symbol is verbally, because it's important that you understand that a less than means that numbers are going to be below the value, you can use this little trick. If you notice the less than symbol, if you were to straighten up the one side, it would create an L. L for less than. So I'm just trying to throw in a little tip that might help you to remember what these inequality symbols represent. So when we're graphing inequalities, the inequality symbol, you want the variable to be on the left-hand side. So when we have the variable on the left-hand side and we're graphing, the way it's going to look is with the X is less than some value, you're going to draw a circle on the number line at that value that it's less than. And then you're going to shade the number line to the left. Now notice that it's an open circle. Because it's just less than, it does not include. To represent that in a picture format, you would leave your circle open at that number. If you have the less than or equal to, the only difference in the graph is you're going to close the circle at that value because it also can include that value. And you're going to shade to the left. When we have a greater than symbol, the variable's on the left-hand side, and it's greater than, you're going to have an open circle because it's not included, and now we're going to be shading to the right. It means it's going to get larger and larger. If you notice on the number line, numbers get larger and larger to the left. So that's why you're shading the number line to the left for a greater than. And then the greater than or equal to would close the circle to mean it includes that number, and then you're going to shade to the left, or the right, because it's going to get larger and larger. So here's a keynote. A keynote is if the variable is on the left-hand side, and that's the key for inequalities, if the variable is on the left-hand side, the inequality symbol points in the direction you should be shading. So if you notice here, the inequality symbol almost acts like an arrow, pointing in the direction to shade. So the key point that I'm making is if the variable is on the left-hand side, the inequality will point in the direction you shade. But if the variable is not on the left-hand side, you might want to turn things around. So another key thing here is another way of writing inequalities. So we can write inequalities in Setbuilder Notation. And Setbuilder Notation is used in other types of mathematics. So it's important to understand what it would look like. So you would have a variable, it would be inside braces with the variable, and then you're going to have a bar, and it's going to give you the condition. And that condition is going to be that inequality. So let's do this example here. So just to explain, we're saying that our X variable is greater than or equal to 5. And it's just written in Setbuilder Notation with the brackets. So we end up having, and how this would be read is the set of all x's, and that's what that means, such that, so our pipe or our bar is just saying such that x is greater than or equal to 5. So we're going to be doing Setbuilder notation just to familiarize ourselves with the way that we will see it in future mathematics. So now here is a graph. We're asked to graph an inequality, but the inequality, the variable's on the right-hand side. So you want to be careful. When the variable's on the right-hand side, you're actually shading in the opposite direction of the inequality symbol because it's read oppositely. It's telling me that -2 is greater than or equal to x, but what I want to know is what x is. So we would actually have to read this backwards. X is less than or equal to a -2. So either you're going to switch everything around if the variable is not on the left-hand side, or another thing too that I'd like to kind of do is if you had it written down on a piece of paper, if you turn that piece of paper upside down, it would show you x on the left-hand side. And then you can just rewrite it properly, and you'd end up with x is less than or equal to a -2. So the important piece here is to understand that when you're graphing your solution, that the variable, it's easier to figure out which way to shade if the variable's on the left-hand side, because then our inequality acts as a direction of shading. So again, remember when you have the less than or equal to, you're going to have a closed circle, and we're going to be shading for this particular example to the left. And then the set building notation, if I were to write this in set building notation, it would be the braces with the x and the bar stating that my x variable is less than or equal to 2. So I just want you to be familiar with set building notation. You'll see it in the exercises, and you'll see it in future mathematics. But when the variable's not on the left-hand side, be careful in which you graph. So now when we're talking about solving inequalities, you follow the same steps as solving an equation. So when we have one rule that we need to understand is we're going to be solving inequalities, we're using the same steps to solve inequalities that we did with equations, but there's one rule that we're going to need to understand, and that is when we solve, if you're multiplying or dividing by a negative number, you're going to need to flip the inequality symbol. So the key thing here is that flipping, if at the very last step you did a multi-step inequality and you multiply or divide by a negative number, you're going to need to flip the inequality symbol. So I wanted to just show you what this might look like. We did a multi-step inequality, and we have one last step to take, and I have here -5x is less than or equal to 10. Well, I need to solve for x. I need to get x on one side of the inequality by itself. And remember, when a number is attached to a variable, the inverse, it's multiplication, so the inverse operation would be division. But notice here, I have to divide by a -5. And because my last step, I'm dividing by a negative, that's going to make that inequality symbol flip. So when you divide through or multiply by a negative number to solve the inequality, you're going to need to flip the inequality symbol in your solution. So in this example, my solution would be x is greater than or equal to a -2. So be careful now, because when you have this last step, you did a multi-step inequality, you have one more step to go, and you have to divide here. And we're dividing by a +5 to solve. So because it's positive, I am not flipping the inequality. The inequality stays in the same direction. It doesn't matter what's on the other side of the inequality. It just matters what's attached to the variable and what you need to do to get the variable by itself. So in this case, the inequality symbol would not flip. It would stay in the same direction, and my solution would be x is less than a -2. So I'm just trying to show you where this rule would apply when you're solving inequalities. And you only really need to think about this rule at the very last step. So when we do two-step equations, I'm just reviewing two-step equations, two-step inequalities work the same way. You want to first undo the addition or subtraction by doing the inverse operation, and then you'll deal with what's attached to the variable, whether it's multiplication or division. So two-step inequalities work the same way as two-step equations, and we're going to do an example. So I want to isolate the variable on one side of the inequality symbol. So it's a two-step here. The first thing I'm going to do is I'm going to subtract 5 from both sides. Now I have to divide, and you always want to think at the very last step, do I need to flip the inequality symbol? And in this case I'm dividing, but I'm dividing by a positive, therefore I do not need to flip the inequality symbol. So my solution would be x is less than or equal to 7. So now you're going to need to graph this, and when you graph it, you're going to use a closed circle at 7, and then you're going to shade to the left. So this is what the graph would look like for the solution set x is less than or equal to 7. And then again, I just want you to get familiar with the set building notation. If I'm given this and I'm asked to write it in set building notation, this is what it would look like. The brace is x, and then the bar where x is less than or equal to 7. So notice here you have a negative x is greater than 19. Well, remember, you're not completely done solving if something is left with x. And because there's a negative left with the x, that means that it's multiplication, and the inverse would be division. Now remember, I'm dividing through by a -1, and because I'm dividing by a negative, that rule's going to apply. And that rule means I have to flip the inequality because I'm dividing by a negative. So my solution for this inequality would end up being x is less than a -19. So very important that your very last step you think of that rule. So now again it's less than, so I'm going to end up having an open circle at -19, and we're going to be shading to the left because it's less than. Now notice this again, it's a two-step. Don't let the fraction throw you off. It's a two-step inequality. With a two-step inequality, the first thing you're going to do is do the addition or subtraction. So in this case, I'm adding 9 to both sides of the inequality. So I'm going to be left with that 5/7x is greater than a -20. Now remember, when you have a fraction attached to a variable and you want that variable to have a coefficient of 1, you need to use the reciprocal to multiply by to get the coefficient of 1. And remember, whatever you do to one side of the inequality, you have to do to the other. So I'm multiplying both sides by the reciprocal of 5/7, which is 7/5, and then you're going to have a whole number over times by a fraction, so you're going to want to put that whole number over 1. Now you simplify, and you're going to multiply across. So we end up getting x here, and be careful, you want to make sure you don't lose that negative sign. X is greater than a -28. The inequality symbol stays in the same direction because I'm not multiplying or dividing by a negative to solve. So this would be my solution. I end up having an open circle at -28, and now I'm shading to the right because it's greater than. So now notice this one. I want to solve for the variable, and it's a two-step inequality. The first thing I'm going to do is remove that +26. The inverse operation of +26 would be -26 or -26. I minus it from both sides, and I'm left with that -3x, or that -3x is greater than or equal to 6. So now the last step, I have to divide, and I'm dividing by a negative, and whenever you divide by a negative, That means you have to flip that inequality symbol. So you're going to flip that inequality symbol for the solution, and you end up with x is less than or equal to a -2. We're going to graph this solution. It's going to be a closed circle because I have less than or equal to, and we're going to shade to the left. Now notice this one. I have an expression over top of a number, and I want to solve for the variable. Well, that's really division. Okay, so that whole expression, x plus 2, is being divided by 3. So in order to get to that variable x on top, I need to first undo that division. So you're going to multiply both sides by 3 to get rid of the division on the left-hand side. And then you'll be left with x plus 2 is less than 21. And now you can solve for x by subtracting 2 from both sides, and your solution here will be x is less than 19. So now you're going to graph your solution. Again, it's an open circle at 19, and you're shading to the left because it's a less than inequality. Pause and try. So the first thing you're going to do here is subtract that 11 from both sides, and you're left with a -3x is less than a -6. Now remember, you're going to divide through by a -3, which makes that inequality symbol flip. So your solution here is x is greater than 2. And now you're going to graph it. It's going to be an open circle, and you're shading to the right. Open circle at 2. Pause and try. So don't let this one throw you off. It's a two-step inequality. You want to first remove that plus 5 by subtracting 5 from both sides. And then you see here x over 2 really means division, and the inverse operation would be multiplication. So you end up getting x is greater than a -28. You're going to have an open circle at a -28, and you're shading to the right. Pause and try. Two-step inequality, you're going to add 6 to both sides. You're going to multiply both sides by the reciprocal of 3 over 4 to get that coefficient of x to be 1. Remember to put that whole number over 1, simplify, and multiply across, and you get your solution. X is less than or equal to 20. So you're going to have a closed circle at 20, and you're going to shade to the left. Pause and try. So remember, that expression on top you leave alone until you get rid of that division of 5. Multiply both sides by 5. That's the inverse of division. That's going to cancel out that 5. Then you're going to be left with x minus 6 is less than or equal to 55. And then you add 6 to both sides. You get x is less than or equal to 61. You're going to graph it. It's going to be a closed circle at 61, and you're shading to the left. So now when we talk about multi-step inequalities, it works the same way as multi-step equations. Always do the distributive property if there's parentheses in the problem. Then you want to combine like terms, and like terms will be on the same side of the inequality symbol. So make sure you're combining them and not changing their signs. And then you start moving. Remember, don't start moving until you clean up the sides. And when you move, so now when you move, if you have variables on opposite sides of the inequality symbol, you're going to have to change the sign to move. And then you're going to have a two-step inequality. You'll undo that addition or subtraction, and then you'll deal with what's attached, that multiplication or division. And at this point, at the very last step, is when you want to think of that rule. If you're multiplying or dividing by a negative, you're going to need to flip the inequality symbol. So you only need to think about it at the very last step. So here's a multi-step inequality. The first thing it states is I have parentheses. That means I have to do the distributive property. So I always double check your distributive property. 3 times x is 3x. 3 times 5 is 15. And then I'm bringing everything else down. Now I'm going to need to combine like terms, and those like terms is that plus 15 plus 3. So I get 3x plus 18 is greater than or equal to 51. Now it's a two-step inequality. You're going to subtract 18 from both sides, and then you're going to divide through by 3. Thinking of that rule, are you dividing by a negative? No, so it ends up staying in the same direction. So we get x is greater than or equal to 11. You'll end up with a closed circle at 11, and you're shading to the right. Pause and try. So you do the distributive property, you combine like terms, and then you get the variable by itself, subtracting 38, dividing through by 6, thinking of that rule, do I need to flip? No, because I'm dividing by a positive. So my solution here is x is less than a negative 8. So we're going to graph it. It's going to be an open circle, and we're shading to the left.